64. Here's the deal. We are doing derivatives of inverse trigonometric functions. So basically, we want to know what the derivative of arcsine is. Where x is the x that we know and love, right, the variable, and a is a number. It's a constant. Okay, so how do we do this?
We're getting a derivative.
We are trying to take the derivative. Here's how. Are you ready? And I'm gonna eventually we'll find out that you just memorize them because it's not worth the time. But let's go through this suffering. I don't know the derivative of this, but I do know the derivative of sine. So let me undo this by taking sine of both sides. Can we do sine of arcsine? Sure, why not? The suffering continues, right? So, sine of y, just a sine of y. Sine of arcsine is x over a. Can I take the derivative of this? Kind of, right? I know the derivative of sine, like it's not y equals anymore, so I have to do implicit differentiation, right? So sine of y, the derivative would be cosine of y dy. The derivative of x over a is simply 1 over a dx. So if I want to solve for dy by dx, which would be the derivative, 1 over a cosine of y. Now, what's the problem with this? Well, the problem is it's calculus, and it is a problem. Ha 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 ha. Is this in terms of x? No. So does that derivative help us? No. We have to do some extra work to get it back in terms of x. Now, here's what we know. Watch this. Y is, I almost used a highlighter instead of a marker. Y is right here. It's arcsine of x over a. Can I plug that in? Sure. Remember those horrible pre-calc problems where they're like, find sine of arcsine of blah, 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 right? We've done those. We've suffered long. Cosine of y would be cosine of arcsine of x over a. Now, how did we do those problems way back when in the pre-calculus years? What does arcsine give you? Like what kind of quantity do you receive when you take the arcsine of something? Let's try this one. What's arcsine of 1/2?
Oh, degrees.
Gives you an angle, right? Gives you an angle. That's the opposite of sine, because sine of 30 is 1/2. Arcsine is the inverse function, so it does the opposite. It takes in the number and gives you the angle. So this arcsine of x over a defines an angle. Which angle does it define? Great question. It defines the angle such that the opposite side is x, the hypotenuse is a. Because sine is opposite over hypotenuse, x is on top, a is on the bottom. Do I actually have to find the numerical angle? No. So what do I do now? Well, I want cosine of this angle. Cosine requires the adjacent side. So I'm gonna have to find the adjacent side. What is this side? Sure, let's call it b. So b squared plus x squared equals a squared. So b squared equals a squared minus x squared. B equals the square root of a squared minus x squared. Horrible? Not really. You guys stuck?
No, I'm a Tony.
Okay, got it. So, what is cosine of that angle? Adjacent over hypotenuse. So those a's cancel. And now we have the derivative of arcsine. The same process can be repeated for all the rest of them. Okay? So for arctangent, take tangent on both sides, draw the triangle, take the derivative, you get the following.
Okay.
Arc secant don't write this yet. I have no clue if it's correct.
So 1/2. I know that part, but like.
Okay, so those three are correct. So you go through that same process. Do I encourage you to do that? Absolutely not. Don't waste your time. What I would say is this. Okay. You should memorize these three because the other three are simply this but minus. Okay. So memorize the first three, don't memorize the second three, and keep the procedure for finding them as part of your wealth of cool party tricks that you can use in the future. Okay.